Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Vocational Education and Training, SOVET, Master's Degree Programs, Master of Science, Information Security, MSCIS, Semester 3, MCS to 26 Data Science and Big Data, Block-1 Basics of Data Science, Unit-1 Introduction to Data Science, 1.0 Introduction. The Internet and communication technology has grown tremendously in the past decade, leading to generation of large amount of unstructured data. This unstructured data includes data such as unformatted textual, graphical, video, audio data, etc., which is being generated as a result of people use of social media and mobile technologies. In addition, as there is a tremendous growth in the digital ecosystem of organization, large amount of semi-structured data, like XML data, is also being generated at a large rate. All such data is in addition to the large amount of data that results from organizational databases and data warehouse. This data may be processed in real time to support decision-making process of various organizations. The discipline of data science focuses on the processes of collection, integration, and processing of large amount of data to produce useful decision-making information, which may be useful for informed decision-making. This unit introduces you to the basic concept of data sciences. This unit provides an introduction to different types of data used in data science. It also points to different types of analysis that can be performed using data science. Further, the unit also introduces some of the common mistakes of data science. 1.1 Objectives. At the end of this unit, you should be able to times define the term data science in the context of an organization, times explain different types of data, times list and explain different types of analysis that can be performed on data, times explain the common mistakes about data size, times define the concept of data dredging, times list some of the applications of data sites, times define the life cycle of data science. 1.2 Data science definition. Data science is a multidisciplinary science with an objective to perform data analysis, to generate knowledge that can be used for decision-making. This knowledge can be in the form of similar patterns or predictive planning models, forecasting models, etc. A data science application collects data and information from multiple heterogeneous sources, cleans, integrates, processes, and analyzes this data using various tools, and presents information and knowledge in various visual forms. As stated earlier, data science is a multidisciplinary science, as shown in Figure 1. Figure 1. Data science. What are the advantages of data science in an organization? The following are some of the areas in which data science can be useful. Times it helps in making business decisions such as deciding the health of companies with whom they plan to collaborate. Times it may help in making better predictions for the future such as making strategic plans of the company based on present trends, etc. Times it may identify similarities among various data patterns leading to applications like fraud detection, targeted marketing, etc. In general, data science is a way forward for business decision-making, especially in the present-day world, where data is being generated at the rate of zettabytes. Data science can be used in many organizations. Some of the possible usage of data science are as given below. Times it has great potential for finding the best dynamic route from a source to destination. Such application may constantly monitor the traffic flow and predict the best route based on collected data. Times it may bring down the logistic costs of an organization by suggesting the best time and route for transporting foods. Times it can minimize marketing expenses by identifying the similar group buying patterns and performing selective advertising based on the data obtained. Times it can help in making public health policies, especially in the cases of disasters. Times it can be useful in studying the environmental impact of various developmental activities. Times it can be very useful in savings of resources in smart cities. 1.3 Types of data. type of data is one of the important aspects which determines the type of analysis that has to be performed on data. In data science, the following are the different types of data that are required to be processed: 1. Structured data, 2. Semi-structured data, 3. Unstructured data, 4. Data streams, structured data. Since the start of the era of computing, computer has been used as a data processing device. However, it was not before 1960s when businesses started using computer for processing their data. One of the most popular language of that era was Common Business-Oriented Language, COBOL. COBOL had a data division, which used to represent the structure of the data being processed. This was followed by a disruptive seminal design of technology by A.E. F. Codd. This led to creation of Relational Database Management Systems, RDBMS. RDBMS allows structured storage, retrieval and processing of integrated data of an organization that can be securely shared among several applications. The RDBMS technology also supported secure transaction, thus became a major source of data generation. Figure 2 shows the sample structure of data that may be stored in a relational database system. One of the key characteristics of structured data is that it can be associated with a schema. In addition, each schema element may be related to a specific data type: customer, cust ID, cust name, cust phone, cust address, cust category, cust PN, cust Aadhaar. Account, account number, custodo first account holder, account type, account balance, joint holders, account number, cust ID, transaction, trans date, trans type, account number, amount of transaction. Figure 2. A sample schema of structured data. The relational data is structured data, and large amount of this structured data is being collected by various organizations as backend to most applications. In 90s, the concept of a data warehouse was introduced. A data warehouse is a time-invariant, subject-oriented aggregation of data of an organization that can be used for decision-making. A data in a data warehouse is represented using dimension tables and fact tables. The dimensional tables classifies the data of fact tables. You have already studied various schemas in the context of data warehouse in MCS 221. The data of data warehouse is also structured in nature and can be used for analytical data processing and data mining. In addition, many different types of database management systems have been developed, which mostly store structured data. However, with the growth of communication and mobile technologies, many different applications became very popular, leading to generation of very large amount of semi-structured and unstructured data. These are discussed next. Semi-structured data. As the name suggests, semi-structured has some structure in it. The structure of semi-structured data is due to the use of tags or key-value pairs. The common form of semi-structured data is produced through XML, JSON objects, server, logs, AD data, etc. The example of semi-structured data is shown in the Figure 3. Figure 3. Sample semi-structured data. Unstructured data. The unstructured data does not follow any schema definition. For example, a written text-like content of this unit is unstructured. You may add certain headings or metadata for unstructured data. In fact, the growth of Internet has resulted in generation of zettabytes of unstructured data. Some of the unstructured data can be as listed below: times large written textual data such as email data, social media data, etc., times unprocessed audio and video data, times image data and mobile data, times unprocessed natural speech data, times unprocessed geographical data. In general, this data requires huge storage space, newer processing methods, and faster processing capabilities. Data streams. A data stream is characterized by a sequence of data over a period of time. Such data may be structured, semi-structured or unstructured, but it gets generated repeatedly. For example, IoT devices like weather sensors will generate data stream of pressure, temperature, wind direction, wind speed, humidity, etc. for a particular place where it is installed. Such data is huge for many applications are required to be processed in real time. In general, not all the data of streams is required to be stored, and such data is required to be processed for a specific duration of time. 1.3.1 Statistical data types. There are two distinct types of data that can be used in statistical analysis. These are categorical data and quantitative data. Categorical or qualitative data. Categorical data is used to define the category of data. For example, occupation of a person may take values of the categories business, salaried, others, etc. The categorical data can be of two distinct measurement scales called nominal and ordinal, which are given in Figure 4. If the categories are not related, then categorical data is of nominal data type. For example, the business category and salaried categories have no relationship. Therefore, it is of nominal type. However, a categorical variable like age category, defining age in categories 0 or more but less than 26, 26 or more but less than 46, 46 or more but less than 61, more than 61, has a specific relationship. For example, the person in age category more than 61 are elder to person in any other age category. Quantitative data. Quantitative data is a numeric data which can be used to define different scale of data. The qualitative data is also of two basic types, discrete, which represents distinct numbers like 2, 3, 5, or continuous, which represent a continuous values of a given variable. For example, your height can be measured using continuous scale. Measurement scale of data. Data are raw facts. For example, student data may include name, gender, age, height of student, etc. The name typically is a distinguishing data that tries to distinctly identify two data items, just like primary key in a database. However, the name data or any other identifying data may not be useful for performing data analysis in data science. The data such as gender, age, height may be used to answer queries of the kind, is there a difference in the height of boys and girls in the age range 10 to 15 years? One of the important questions is, how do you measure the data so that it is recorded consistently? Stanley Stevens, a psychologist, defined the following 4 characteristics that any scale that can be measured times every representation of the measure should be unique. This is referred to as identifier of a value, IDV, dot, times the second characteristics is the magnitude, M, which clearly can be used to compare the values. For example, a weight of 70.5 kilograms is more than 70.2 kilograms, times third characteristics is about equality in intervals, EI, used to represent the data. For example, the difference between 25 and 30 is 5 intervals, which is same as the difference between 41 to 46, which are also 5 intervals, times the final characteristics is about a defined minimum or zero value, MZV. For example, in Kelvin scale, temperature have an absolute zero value, whereas the intelligent quotient cannot be defined as zero. Based on these characteristics, 4 basic measurement scales are defined. Figure 4 defines these measurements, their characteristics, and examples. Figure 4. Measurement scales of data. 1.3.2 Sampling. In general, the size of data that is to be processed today is quite large. This leads you to the question whether you would use the entire data or some representative sample of this data. In several data science techniques, sample data is used to develop an exploratory model also. Thus, even in the data science, sample is one of the ways which can enhance the speed of exploratory data analysis. The population in this case may be the entire set of data that you may be interested. Figure 5 shows the relationships between population and sample. One of the questions which is asked in this context is what should be the size of a good sample. You may have to find the answer in the literature. However, you may please note that a good sample is representative of its population. One of the key objectives of statistics, which uses sample data, is to determine the statistic of the sample and find the probability that the statistic developed for the sample would determine the parameters of population with a specific percentage of accuracy. Please note the terms stated above are very important and explain in the following table. Look at the screen. Next, we discuss different kind of analysis that can be performed on data. 1.4 Basic methods of data analysis. The data for data science is obtained from several data sources. This data is first cleaned of errors, duplication, aggregated, and then presented in a form that can be analyzed by various methods. In this section, we define some of the basic methods used for analyzing data. These are descriptive analysis, exploratory data analysis, and inferential data analysis. 1.4.1 Descriptive analysis. Descriptive analysis is used to present basic summaries about data. However, it makes no attempt to interpret the data. These summaries may include different statistical values and certain graphs. Different types of data are described using different ways. The following example illustrates this concept. Example 1. Consider the data given in the following figure 6. Show the summary of categorical data in this figure. Please note that enrollment number variable need not be used in analysis, so no summary data for enrollment number is to be found. Descriptive of categorical data. The gender is a categorical variable in figure 6. The summary in this case would be in terms of frequency table of various categories. For example, for the given data, the frequency distribution would be. In addition, you can draw bar chart or pie chart for describing the data of gender variable. The pie chart for such data is shown in figure 7. Details of different charts are explained in Unit 4. In general, you draw a bar graph in case the number of categories is more descriptive of quantitative data. The height is a quantitative variable. The descriptive of quantitative data is given by the following two ways. 1. Describing the central tendencies of the data. 2. Describing the spread of the data. Central tendencies of quantitative data. Mean and median are two basic measures that define the center of data, though using different ways. Interestingly, mean and mode may be useful in determining the nature of data. The following table describes these conditions. Figure 8. Mean and median for possible data. The concept of data distribution is explained in the next unit. Mode. Mode is defined as the most frequent value of a set of observation. For example, in the data of example 2, the value 14, which occurs twice, is the mode. The mode value need not be a mid-value, rather it can be any value of the observations. It just communicates the most frequently occurring value only. In a frequency graph, mode is represented by peak of data. For example, in the graphs shown in figure 8, the value corresponding to the peaks is the mode spread of quantitative data. Another important aspect of defining the quantitative data is its spread or variability of observed data. Exploratory data analysis was suggested by John Turkey of Princeton University in 1960 as a group of methods that can be used to learn possibilities of relationships amongst data. After you have obtained relevant data for analysis, instead of performing the final analysis, you may like to explore the data for possible relationships using exploratory data analysis. In general, graphs are some of the best ways to perform exploratory analysis. Some of the common methods that you can perform during exploratory analysis are as follows. 1. As a first step, you may perform the descriptive of various categorical and qualitative variables of your data. Such information is very useful in determining the suitability of data for the purpose of analysis. This may also help you in data cleaning, modification, and transformation of data. For the qualitative data, you may create frequency tables and bar charts to know the distribution of data among different categories. A balanced distribution of data among categories is most desirable. However, such distribution may not be possible in actual situations. Several methods has been suggested to deal with such situations. Some of those will be discussed in the later units. B. For the quantitative data, you may compute the mean, median, standard deviation, skewness and kurtosis. The kurtosis value relates to peaks determined by mode in the data. In addition, you may also draw the charts like histogram to look into frequency distribution. 2. Next, after performing the univariate analysis, you may try to perform some bivariate analysis. Some of the basic statistics that you can perform for bivariate analysis includes the following. A. Make two-way table between categorical variables and make related, stacked bar charts. You may also use chi-square testing find any significant relationships. B. You may draw side-by-side box plots to check if the data of various categories have differences. C. You may draw scatter plot and check the correlation coefficient, if that exists between two variables. 3. Finally, you may like to look into the possibilities of multivariate relationships amongst data. You may use dimensionality reduction by using techniques feature extraction or principal component analysis. You may perform clustering to identify possible set of classes in the solution space, or you may use graphical tools like bubble charts to visualize the data. It may be noted that exploratory data analysis helps in identifying the possibilities of relationships amongst data, but does not promises that a causal relationship may exist amongst variables. The causal relationship has to be ascertained through qualitative analysis. Let us explain the exploratory data analysis with the help of an example. Please note that box plot of figure 10 shows that on an average height of male students is more than the female student. Does this result applies in general for the population? For answering this question, you need to find the probability of occurrence of such sample data. Need to determine the probability. Therefore, inferential analysis may need to be performed. 1.4.3 Inferential analysis. Inferential analysis is performed to answer the question that what is the probability of that the results obtained from an analysis can be applied to the entire population. A detailed discussion on various terms used in inferential analysis in the context of statistical analysis had been done in Unit 2. You can perform many different types of statistical tests on data. Some of these well-known tools for data analysis are listed in the figure 11. Test and why performed. Univariate analysis, z-test or t-test to determine if the computed value of mean of a sample can be applicable for the population and related confidence interval. Bivariate chi-square test to test the relationship between two categorical variables or groups of data. To sample t-test to test the difference between the means of two variables or groups of data. One way ANOVA to test the difference in mean of more than two variables or groups of data. F-tested can be used to determine the equality of variance of two or more groups of data. Correlation analysis determines the strength of relationship between two variables. Regression analysis examines the dependence of one variable over a set of independent variables. Decision trees. Supervised learning used for classification, clustering. Non-supervised learning. You may have read about many of these tests in data warehousing and data mining, and artificial intelligence and machine learning course. In addition, you may refer to further readings for these tools. The following example explains the importance of inferential analysis. Figure 12. The output of to sample t-test to tail Figure 12 shows that the mean height of the female students is 167 centimeters, whereas for the male students it is 173 centimeters. The variance of female candidates is 94.5, whereas for male candidate it is 63.5. Each group is interpreted on the basis of 5 observations. The computed t-value is 1.07 and p-value is 0.32. As the p-value is greater than 0.05, therefore you can conclude that you cannot conclude that the average male student height is different from average female student height. 1.4.4 Predictive analysis. With the availability of large amount of data and advanced algorithms for mining and analysis of large data have led the way to advanced predictive analysis. The predictive analysis of today uses tools from artificial intelligence, machine learning, data mining, data stream processing, data modeling, etc. to make prediction for strategic planning and policies of organizations. Predictive analysis uses large amount of data to identify potential risks and aid the decision-making process. It can be used in several data-intensive industries like electronic marketing, financial analysis, healthcare applications, etc. For example, in the healthcare industry, predictive analysis may be used to determine the support for public health infrastructure requirements for the future based on the present health data. Advancements in artificial intelligence, data modeling, machine learning has also led to prescriptive analysis. The prescriptive analysis aims to take predictions one step forward and suggest solutions to present and future issues. A detailed discussion on these topics is beyond the scope of this unit. You may refer to further readings for more information on these 1.5 common misconceptions of data analysis. In this section, we discuss 3 misconceptions that can affect the result of a data science. These misconceptions are explained with the help of an example. Only correlation is not causation. Correlation analysis establishes relationship between 2 variables. For example, consider 3 variables, namely attendance of student, attend, marks obtained by student, marks, and weekly hours spent by a student for the study. While analyzing data, you found that there is a strong correlation between the variables attend and marks. However, does it really mean that higher attendance causes students to obtain better marks? There is another possibility that both study and marks, as well as study and attend, are correlated. A motivated student may be spending higher number of hours at home, which may lead to better marks. Similarly, a motivated student who is putting a greater number of hours in his/her study may be attending to school regularly. Thus, the correlation between study to marks and study to attend results in a non-existing correlation attend to marks. This situation is shown in Figure 13, Simpson's paradox. Simpson paradox is an interesting situation which sometimes leads to wrong interpretations. Consider 2 universities, say University 1 and University 2, and the pass-out data of these universities. University student passed percent, student failed percent, total U1 48 50 97%, 153%, 5000, U2 1960 98%, 42%, 2000. Figure 14. The results of the universities, as you may observe from the data as above. The University U2 is performing better as far as passing percentage is concerned. However, during a detailed data inspection, it was noted that both the universities were running basic adult literacy program, which in general has a slightly poor result. In addition, the data of the literacy program is to be compiled separately. Therefore, the B data for the university would be Figure 15. The result after a new grouping is added. You may observe that due to the additional grouping due to adult literacy program, the corrected data shows that U1 is performing better than U2 as the pass-out rate for general program is same and pass out rate for adult literacy program is better. From U1. You must note the changes in the percentages. This is the Simpsons paradox. Data dredging. Data dredging, as the name suggests, is extensive analysis of very large data sets. Such analysis results in generation of large number of data associations. Many of those associations may not be causal, thus requires further exploration through other techniques. Therefore, it is essential that every data association with large data set should be investigated further before reporting them as conclusion of the study. 1.6 Applications of data science. Data science is useful in analyzing large data sets to produce useful information that can be used for business development and can help in decision-making process. This section highlights some of the applications of data science. Applications using similarity analysis. These applications use similarity analysis of data using various algorithms, resulting into classification or clustering of data into several categories. Some of these applications can be Time Spam Detection System. This system classifies the emails into spam and non-spam categories. It analyzes the IP addresses of mail origin, word patterns used in mails, word frequency, etc. to classify a mail as spam or not. Times Financial Fraud Detection System. This is one of the major applications for online financial services. Basic principle is once again to classify the transactions as safe or unsafe transactions based on various parameters of the transactions. Times recommendation of products. Several e-commerce companies have the data of your buying patterns, information about your searches to their portal, and other information about your account with them. This information can be clustered into classes of buyers, which can be used to recommend various products for you. These applications primarily help you in finding content on the web more effectively. Some of the applications in this section would be the search algorithms used by the various search engines. These algorithms attempt to find the good websites based on the search terms. They may use tools related to semantic of your term, indexing of important website and terms, link analysis, etc. In addition, the predictive text use of browser is also an example of use of applications related to healthcare system. The data science can be extremely useful for healthcare applications. Some of the applications may involve processing and analyzing images for neonatal care or to detect possibilities of tumors, deformities, problems in organs, etc. In addition, there can be applications to establishing relationships of diseases to certain factors, creating recommendations for public health based on public health data. Genomic analysis, creation and testing of new drugs, etc. The possibilities of use of streaming data for monitoring the patients is also a potential area for use of data science in healthcare. Applications related to transport sector. These applications may investigate the possibilities of finding best routes, air, road, etc. For example, many e-commerce companies need to plan the most economical ways of logistic support from their warehouse to the customer. Finding the best dynamic route from a source to destination with dynamic load on road networks, etc. This application will be required to process the streams of data. In general, data science can be used for the benefit of society. It should be used creatively to improve the effective resource utilization, which may lead to sustainable development. The ultimate goal of data science applications should be to help us protect our environment and human welfare. 1.7 Data Science Life Cycle. So far, we have discussed about various aspects of data science in the previous sections. In this section, we discuss about the life cycle of a data science-based application. In general, a data science application development may involve the following stages: data science project requirements analysis phase. the first and foremost step for data science project would be to identify the objectives of a data science project. This identification of objectives is also coupled with the study of benefits of the project, resource requirements, and cost of the project. In addition, you need to make a project plan, which includes project deliverables and associated time frame. In addition, the data that is required to be used for the project is also decided. This phase is similar as that of requirement study and project planning and scheduling, data collection and preparation phase. In this phase, first all the data sources are identified, followed by designing the process of data collection. It may be noted that data collection may be a continuous process. Once the data sources are identified, then data is checked for duplication of data, consistency of data, missing data, and availability timeline of data. In addition, data may be integrated, aggregated, or transformed to produce data for a defined set of attributes, which are identified in the requirements phase, descriptive data analysis. Next, the data is analyzed using univariate and bivariate analysis techniques. This will generate descriptive information about the data. This phase can also be used to establish the suitability and validity of data as per the requirements of data analysis. This is a good time to review your project requirements vis-a-vis collected data, characteristics, data modeling, and model testing. Next, a number of data models based on the data are developed. All these data models are then tested for their validity with test data. The accuracy of various models are compared, contrasted, and a final model is proposed for data analysis, model deployment, and refinement. The tested best model is used to address the data science problem. However, this model must be constantly refined as the decision-making environment keeps changing and new data sets and attributes may change with time. The refinement process goes through all the previous steps again. Thus, in general, data science project follows a spiral of development. This is shown in Figure 16. Figure 16, a sample life cycle of data science project. 1.8 Summary. This unit introduces basic statistical and analytical concepts of data science. This unit first introduces you to the definition of the data science. Data science as a discipline uses concepts from computing, mathematics, and domain knowledge. The types of data for data science is defined into different ways. First, it is defined on the basis of structure and generation rate of data. Next, it is defined as the measures that can be used to capture the data. In addition, the concept of sampling has been defined in this unit. This unit also explains some of the basic methods used for analysis, which includes descriptive, exploratory, inferential, and predictive. Few interesting misconceptions related to data science has also been explained with the help of example. This unit also introduces you to some of the applications of data science and data science life cycle. In the ever-advancing technology, it is suggested to keep reading about newer data science applications. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.